All right, this is a video that is going to act as a tutorial for MathCad. I would strongly recommend that students in Thermo use MathCad as often as possible. It's good to know how to use your calculator and to be able to do calculations with, punching things in your calculator and making sure you do things in the right order and know how to perform under time constraints. But I think the advantages of using MathCAD are just too large to ignore. And I think students in the previous iteration of teaching this class, I saw a big increase, I think, in comprehension and just being able to work with the calculations because of this. So the first thing first is MathCAD. You should get MathCAD version 15 when you get it from our AICHE department. Do not get MathCAD Prime. MathCAD Prime is a newer but inferior product. MathCAD 15, even though it is older, is the MathCAD version that you should use. And what you'll notice that I use MathCAD. I'm using MathCAD 2000. So this version is over 20 years old. The mathematics are just as good as the mathematical operations are just as good as the new versions. There's a little bit better graphics maybe and better graphing, but overall MathCAD 2000 is just fine. So if you have older versions of MathCAD, those should be fine as well. So here's the MathCAD window, and again, MathCAD 15 may look a little different. I've got some things customized, maybe a little different than what you have, but you open it up to a blank sheet. The nice thing about this is MathCAD is very intuitive, and we'll see that as we go through the example problem. The other thing is the best way to learn MathCAD is to use MathCAD. I am going to start with some simple example problems. As we go through the semester, we will deal with more complex calculations that involve, for example, solving or integration or iterations or vectors, matrices, so on and so forth. And we will cover those as we get to the material. The first thing I do with MathCAD is I go to page setup, and I always adjust the margins to 0.5 inches because the default margin for my version is 1.2, which I think is too wide. So that's the first thing I do. Then the next thing that I want you to do whenever you use MathCAD is always provide a good problem statement. And so for this example problem, I'm going to use problem 223 from your textbook. This is something that we technically haven't covered, but you've probably seen the material anyway, and it's just a good example problem for learning some of the basic operations in MathCAD. And so I just copy and paste this from a Microsoft Word document, and that way we know what problem we're solving and all the information. Now, as we do problems, one of the things that, as we go through the problem-solving strategies, one of the things that I strongly encourage, when appropriate, is to use a schematic. And so, in this problem, we've got an incompressible fluid. So incompressible means that density is constant. It flows steadily, and by steady, we mean steady state, through a conduit of circular cross-section and increasing diameter. So the pipe's getting wider as the fluid flows through it. At location 1, the diameter is 2.5 centimeters, and the velocity is 2 meters per second. At location 2, the diameter is 5 centimeters. And so what we're asked to find the velocity at location 2, and then the kinetic energy change of the fluid between locations 1 and 2. And so this is a simple enough problem that you can probably visualize it in your head without drawing a schematic. But just for the sake of illustration here, I went and drew a schematic. Now MathCAD does not have drawing tools. You can see here there's no real tools for drawing, and so what I did was I just went to PowerPoint and drew a schematic here, just to make sure we can illustrate things. So now I've got my schematic. And so the next thing that I would usually do is I start writing down the given information. And so this is where we actually start entering information into MathCad. And so I'm going to enter the diameter at position 1. And so the nice thing about MathCad is very intuitive. And so I'm just going to say D1. Now I can have D1 as all the same case, but I like to use subscripts where it is convenient to use it. So to do D sub 1 in MathCad, to get a subscript, you type period. So D period, and you see the cursor moves down 1. So that gives me my variable D1. Now I want to assign the value 2.5 centimeters. And so to assign values in MathCad, you use shift semicolon or colon basically. So you press the shift key and the semicolon colon key. And you see that gives you, this is the MathCad assigning a variable sign. And so now I'm going to type, you see the cursor here, 2.5. And the nice thing about MathCad is it keeps tracks of units for me. And so I could have everything unitless and do things, keep track manually, but I'm going to have MathCad do my units for me. And so that's what I'm going to do. So centimeters, I just type in centimeters. I don't have to type a multiplication. I just type in centimeters. MathCad has, if you go to the insert units, you can see all of the units here, all the length units, and then you can go through and see all of the other kinds of units that MathCad uses. And like I said, I prefer SI. So anyway, as long as MathCad has units, things will be should work out well for you. So D1 is 2.5 centimeters, D2, so D dot 2 shift colon is equal to 5 centimeters. And then what else do we know? Just use my arrow key to move over. U, the velocity at position 1, and for linear velocity we usually use U, or you could use V if you wanted, but U dot 1 is equal to 2, and it's meters per second. So M divided by S, so M/S, meters per second. So now that's all my given information. One of the things you need to notice though is that, for example, MathCad will mess you up if I define a variable as M. So a lot of times we use M for mass. If I tried to define a variable M for mass as 5 kilograms, what MathCad thinks I'm doing is I'm defining 1 meter to equal 5 kilograms. So you need to be careful. You need to be careful with these units. So S is seconds, M is meters. Do not use S as a variable and try to assign it something. Do not use M as a variable. Do not use CM as a variable and try to assign it something. All right, so that's how I enter the given information. Then when I'm solving a problem, I need to figure out what I'm solving for. And as I mentioned, I think it's always good to write down an explicit statement of what you're solving for. So the first thing is the velocity at position 2. And so this is just typed in. I've got these things already typed and pasted, so I don't have to spend a lot of time doing it, but this is just typed in. I want to find the velocity at position 2. And so this is where we would then go into our textbook or our notes, and we would find that for an incompressible fluid, a fluid at constant density, and this is from chapter 2 material, or it might have been from your 114 or 202 class, we have this relationship. Density times linear velocity times cross-sectional area at position 1 is equal to density times linear velocity times cross-sectional area at position 2. And what I want you to notice is that I am using this is a bold font equal sign. This is not the assign a value sign that we had up here. All right, how do we get that? And this is what's nice about MathCad, is because I can let MathCad do some symbolic calculations for me if I use this equal sign. And I get this particular equal sign when I'm dealing with variables only by using Control Enter. So if I'm going to type this again a little bit later, I will do that. Now what we know then is that for an incompressible fluid, that means the density is constant, right? And so row 1 is equal to row 2. And so again, I say row 1 is equal to row 2. And let me just retype that for you to show how we get Greek letters. So to get a Greek letter, and I prefer to use Greek letters where I can, row is lowercase r, right, in our English alphabet, so R. And then to get a Greek letter, in MathCad, we type Control G. So R, and then you immediately hit Control G. That gives you the letter row. And then dot 1. So it gives me my subscript 1. Dot 1. Now, to assign a value algebraically or symbolically, I use Control Enter. And that gives me that bold equal sign. And then row 2 is R, Control G, dot 2. So that's how that is entered. All right. And so once that is entered, then I can, and I encourage you when you're using MathCad, put steps of your derivations in place so that you can follow your solution, especially if you make mistakes. So now our formula is u dot 1 times a dot c1, and then I'm going to keep this symbolic equal sign, Control Enter, u dot 2 times, and the multiplication is just your asterisk, so Shift 8 times a dot c2. All right. So we want to find velocity at position 2, which is this. This algebra is really easy, and you can do it in your head. But what I want to show you is that you can have MathCad do symbolic calculations for you. So this is an easy equation. Let's have it do that. So I want to solve for U2. So U2, all right, is going to equal, and so I'm going to type my shift colon, because I'm actually going to assign now a formula to that. And to solve for U2, what I can do is I can go to this equation, I select my variable that I want to solve for, so not AC2, I want to solve for U2. I go up to symbolics, variable, solve. And I click on solve. And lo and behold, MathCad does the solution for me. It solves for U2. And so I do a Control X to cut. Click on this, Control V to paste. And there I've got my value. Now, what you'll see is that now MathCad doesn't realize what AC1 and AC2 are. It just tells me AC1 is not defined, and it will also tell me that AC2 is not defined. And that's because we didn't define the cross-sectional areas. So what I can do here then is just, because MathCad does its calculations from top to bottom and left to right. And so what I can do is say, okay, what is AC1? My cross-sectional area 1, A dot C1 is equal to, that's pi d squared over 4. So pi is lowercase p, Control G. So that's pi. So MathCad knows that this is 3.141592635, blah, 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 times D1, D dot 1. Now squared, I use the caret, so Shift 6. And you see my cursor moves up, D1 squared. Now I want to divide everything by 4. If I just say /4, it's going to raise D1 to the 2/4 power. So I want to select this whole expression. Ideally, well, I could just select D1 squared and divide by 4, or I could select both pi and D1 squared and divide by 4. I'm going to do that to make it look neater. So to do that, all I do is press the space bar. So I press the space bar once, and it selects D1 squared. I press the space bar again, and it selects the whole right side of the equation. If I press the space bar again, it selects everything. That's not what I want. So let's just go back. And now I type in the divided by 4. So that's / and you can see now I have everything nice and neat, divided by 4. And one thing I like to do whenever I do a calculation like this, I also like to check my values, make sure everything's right. So A dot C1. Now, how do I get a value out? This is where, when I defined an equation like this, AC1 shift colon is defined as pi d1 squared over 4. What I do to find the value is I type A dot C dot 1 and then just plain equal sign. Just click on the equal sign, and that is what MathCad uses to define, to calculate and give me the value. And so you can see the different kinds of equal signs, if you will, that MathCad uses. When I'm defining constants or defining variables with values, I use the shift colon. When I'm doing symbolic calculations, I use the control enter, because that enables me to then solve for these numbers, all right? And when I want to find the value, present the value, I just use the plain equal sign. And notice my units are SI base units, all right? I entered my units as centimeters, but now I'm getting everything in square meters, and it's a really small number in square meters. And I don't, this doesn't, it's hard to visualize if this is right. And so what I'm going to do is I'm going to change the units. And this is a nice thing about MathCad. So if I don't want meters squared, say I want centimeters squared. I want centimeters squared, I just click on that. I type centimeters, caret, squared, return, or enter. And now my units are in centimeters squared. I don't have to worry about how many square centimeters are in a square meter, and a lot of students make mistakes when they do those kinds of unit conversions. So I can let MathCad do all that stuff and keep things straight for me. So those are my units. What if I, for some reason, what if I wanted these units to be square inches? I could do that too. Inches squared, 0.761 square inches. Now, I hate English units. I don't like English units, so I'm going to put it back. Oops. Centimeters squared. All right. So then I can do the same thing with A dot C2 is equal to pi, P control G, times D dot 2 squared, and then I select the whole right side with the space bar, divided by 4. So I've got my expression. Now I want to see the value. So A dot C2 plain equal sign, and I'm going to change that to centimeters squared. All right. And so now you see that everything here is defined. There's no error messages in this equation for undefined variables. And so now I can just type in and find out what U2 is. So U dot 2 is equal to 0.5 meters per second. And when I am doing MathCad sheets like this, worksheets, and I would encourage you to do this, always do something like mark your answer. Make sure that you mark what your final answer is. And so I use bold. Sometimes students like to use highlights, or I think with the new MathCad, you can select this and you can do a box fill or something like that, and that's fine. But always make sure you mark your answers. And note, you can type in text. Right now, MathCad thinks this is a variable, a mathematical variable. But as soon as I hit the space key, MathCad realizes that this is now text. And so everything that I type in after this will be text. If I want to delete something, I can select it and hit delete, or I can just select it, select the box and hit Control D, and I delete it. So anyway, this is a simple example with MathCad showing the calculation of the velocity at position 2. We have a schematic. We gave our given information here, defined our variables. We did some very simple algebraic manipulation with the symbolic equal sign. Again, this is something you could have done in your head just as easily and written the final solution down, but As we go through more and more complex equations, doing this symbolic simplification is going to make things a lot easier on you. And it's a lot quicker and less prone to error and mistakes. We did some intermediate calculations of some of these variables, and then we got our answer. So then the next part of the problem is the kinetic energy at position 2. And so now we want to find the change in kinetic energy from position 1 to position 2. If we go into chapter 2, we find this is our equation that we're going to use. And so I use, to get a capital delta, I do capital D, control G. Capital D, control G, KE. And again, I use the symbolic. KE is equal to 1/2. And then I select that, so I make sure that this is like my parentheses, times. Now remember, M stands for meters in MathCad. M in your textbook stands for mass, or maybe M dot for mass flow. MathCad doesn't let you do M dots, so I just write M dot flow, all right? And then times, and then that's delta U, so that's D, control G, oops. Capital D, the delta that we use is control G times or U squared. All right, so this is purely symbolic, and because we've written just delta U squared, we aren't going to be able to do any simplification, but we don't need to. So I'm just going to leave it that way. I use this symbolic equations. Sometimes I use them for actually doing algebraic solutions, but here I've just written this as an equation to use basically as text. All right, I'm not gonna do anything. I'm not going to do anything with it algebraically. Now, what is the mass flow rate? Well, if you look at the problem statement, we don't know what the mass flow rate is, but we do know that the mass flow rate is constant. And if you look at the problem statement, it says to calculate the kinetic energy change per mass basis. And so what that means is we can just take the mass flow rate out of the equation. All right? We can take the mass flow rate out of the equation. And so if our kinetic energy change is on a per mass flow basis, we just take this out, and we have kinetic energy is equal to 1/2 times U2 squared minus U1 squared. All right, and so MathCAD, again, let me just type this. So capital D, KE, all right, that's my change in kinetic energy, shift colon, and then 1 divided by 2, hit the space bar to select that whole fraction, times, and in MathCAD you can use parentheses and brackets, just like you do when you're writing equations by hand, times U dot 2, and then everything is selected there. The U2 is selected, squared, and then I make sure that I select U2 squared minus U dot 1 caret squared. And then I'm going to select this entire expression that goes within the parentheses and then close parentheses. So that makes sure that I have the parentheses in the right place. All right. So I've got my kinetic energy formula. Now I need to display the calculated value. So D, control G, KE, and then just plain equal sign. Plain equal sign. And I get minus 1.85875 sieverts. And I'm guessing that no one in this class has worked with energy units for sieverts. And this is one of the kind of historical things about MathCAD. MathCAD was originally developed for electrical engineering applications. And the sievert is an energy unit that, for some reason, electrical engineers use. If I am giving you a problem where I specifically ask for certain units in the answer, you need to have those units in your final answer. So what do? Well, one thing you could do is you could go to some arcane electrical engineering handbook and figure out or look up online what the conversion factor for joules per kilogram to sieverts is, or I can just let MathCad do the work. And so letting MathCad do the work, see this little cursor here? I just click on that, and I want my answer in joules per kilogram, so let's make it do joules per kilogram. So joules, J is defined in MathCad, that's one of the base IU units, SI units, per kilogram. Enter, I've got my answer. So the kinetic energy change is minus 1.875 joules per kilogram. Does that make sense? Yeah, it makes sense because the linear velocity is getting smaller, right? And the linear velocity is a function of the kinetic energy is a function of the linear velocity. So if the velocity goes down, the kinetic energy goes down. So the kinetic energy at position 2 is less than the kinetic energy at position 1 on a per mass basis. So this is our final answer. So again, we'll mark that as our final answer. And unfortunately, my version Control B doesn't work for bold. I have to go up and actually click that on my screen. What if I asked for the answer in kilojoules per kilogram? And so let's do KE is equal to, and then I do kilojoules. So KJ per kilogram. And note, MathCad doesn't know what a kilojoule is, all right? If I bring my units and I look at energy, you can see all these different energy units. It only knows what joules are. There's no kilojoules in here, so what do? Well, that's another nice thing about MathCad is I can define new units. And so remember, MathCad does its calculations from top to bottom and from left to right, just like we read normal documents. So I am going to define a kilojoule. So KJ is equal to what? That's equal to 1,000 joules. All right. And as soon as I do that, whoops, I got the wrong. Let me fix this. Equals KJ per kilogram. Now I've got my answer. And so if I want it in kilojoules per kilogram, that's what it is. What if I want it in joules per gram? So we get our sieverts, and I want joules per, now what's the unit for mass of gram? Gram, G. What happened there? What happened here? This is another thing about MathCad. What is G? MathCad thinks G is the acceleration due to gravity, right, at the Earth's surface. So that's 9.8 meters per second squared. So G is not the MathCad symbol for gram. It's GM. That is the MathCad unit for gram. And so if I do that, joules per gram, I get the correct answer. All right. So this is just a little tutorial here. This is a simple problem from chapter 2. It's not strictly material that we've covered yet, but the calculations are simple enough that hopefully you can see some of the mechanics of using MathCad for solving a problem. Again, what I strongly emphasize, put the problem statement in your MathCad sheet. Again, this is just copy and paste. And for a lot of the problems, you can, if you need to, you can type the information out, but it's important to have the information for quizzes and exams. I will be giving you the problem statements in Microsoft Word format so that you can access them and copy and paste them into your MathCad sheet. For diagrams, for quizzes and exams, this is not the best of artistic values, but it gets the job done. For schematics, I'm not looking for artistic expertise. I'm looking for a good descriptive diagram that shows you what's going on. And that does the job here. It took me about, I don't know, maybe 30 seconds to get this drawn in PowerPoint and put it in. And so if you want to draw something by hand, take a picture and insert it later, that's fine. Some of the thermodynamics problems, we really need a schematic, but some of the problems that you're going to have for quizzes and exams, you might not really need that much of a schematic. So, but it's a good idea to put something down if you can so that you can visualize what's going on. Then we write our given information. So this is a given information. And then from that, we can start solving our problem. In this case, this problem statement was easy enough that we didn't have to do a lot of work with coming up with assumptions and defining systems and surroundings in real explicit detail. It's pretty obvious that our system is the fluid that's flowing through here. The surroundings is everything else. There's a very simple equation that describes the flow of incompressible fluids through a pipe of varying diameter, and that's what this is. We learned how the different equal signs, if you will, that are used for assigning variables, assigning expressions to a variable, or doing symbolic calculations. Plugging these symbolic calculations in with exponents, with Greek letters, with subscripts, and then using the plain equal sign to get the actual calculated value, and then adjusting our units if necessary to get our answer. So with this will get you started with MathCad. And like I said, as we go through more and more complex problems, we will be adding to your MathCad repertoire, and hopefully by the end of the semester, well, I would say within a few weeks, you should become very comfortable in using MathCad, and by the end of the semester, you will be somewhat of an expert at using MathCad.